and welcome to multiplying and dividing algebraic fractions. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so our method for multiplying algebraic fractions is going to begin with us actually cancelling out common factors to begin with, and then we're going to use the normal multiplying fractions method. We'll multiply the numerators and we'll multiply the denominators. So let's see how that works. So in the first question I have 9a over 8 times 12b over 15. Now in terms of cancelling out the common factors, this is actually about looking at diagonals. We need to find the common factors between 9a and 15 and the common factors between 8 and 12b. So straight away the common factor between 9a and 15, well that would mean we would divide by 3. So this would give me 3a on the top and it would give me 5 on the bottom. I've cancelled out a factor of 3. And then on the other two values, so the common factor between 8 and 12b, well that would be 4. So I'll divide 8 by 4 to get 2, and 12b by 4 to get 3b. And then I will multiply together. So we've cancelled out the common factors. That's our first step. Our second step is just to multiply across the top and across the bottom. So in this case I have 3a times 3b. Well, that's going to be 9ab, and along the bottom 2 times 5 is 10, so that would be 9ab over 10. In the second one we need to do the same. We need to cancel out our common factors, but in this case it's not obvious straight away what those common factors are. The first thing we're going to have to do is actually factorise the expressions. And so at the top of the first bracket I have 3 brackets, well this is going to be x plus 2 when I factorise. At the bottom I've got x squared take away 4x, that would be x brackets x take away 4. On the right hand side I've got x take away 4, there's nothing I'm going to be able to do with that. And I've got x plus 2, there's nothing I'm going to be able to do with that. But now, can I cancel out the common factors? Well, I've got an x plus 2 at the top and an x plus 2 at the bottom. I've got an x minus 4 and an x minus 4. They cancel out. And so what this is actually saying is I'm actually multiplying by 1. And what does multiplying by 1 mean? Well, it means leaving it exactly as it is. So this is just 3 over x. In the final one, I have x squared plus 5x plus 6 over 3x times 6x take away 9 over x squared plus 7x plus 12. This is this has two expressions in the form of x squared plus bx plus c, which means I'm going to need double brackets when it comes to factorising. So in the first one, x squared plus 5x plus 6, I need two numbers that are going to multiply to make positive 6, but add to make positive 5. Well, that's going to be x plus 2 and x plus 3, and that's all over 3x. And for the second fraction at the bottom here, again I'm going to need double brackets. I need two numbers which are going to multiply to make 12 but add to make 7. Well, that's going to be x plus 3, x plus 4. And at the top, am I able to simplify or factorise the top? Well, in this case both numbers can be divided by 3, so that's actually 3 brackets 2x take away 3. Now, do we have common factors? Well, if we have a look on the diagonals, I've got an x plus 3 here and an x plus 3 here, so they have cancelled. Here I have 3x on the bottom and I've got 3 brackets 2x minus 3. Well, is there a common factor there? Well, in this case the common factor is just the 3. And so now when we multiply together, we've got a slightly easier version. We've got x plus 2 being multiplied by 2x take away 3, and on the bottom I have x being multiplied by x plus 4. Now that is a perfectly acceptable answer. We could leave it as that. It may be though that we're asked to show that this is a certain form, so you may need to then actually expand out the brackets. In this case we'd get 2x squared, take away 3x plus 4x, take away 6, and this piece here would simplify to plus x, and that would all be over x squared plus 4x. And so that is another version of exactly what we've got above. So moving on to dividing algebraic fractions. Now the first thing is, if you were dividing any normal fractions, you would use the method copy, change, flip. And basically you are turning a divide question into a multiply question. We're going to do exactly the same here in terms of the algebraic fractions. So we'll copy, change, flip. And then the second two stages are exactly what we've just done for multiplying, because we've turned it into a multiplication question. So let's have a look. 6a divided by 7 divided by 9x over 14. Well, what is our first stage? Well, our first stage is copy, change, flip. So copy, change, flip states that we copy the first fraction, we change the divide to a multiply, and we flip the second fraction. And so what I've got is 6a over 7 times 14 over 9x. Now we just need to go through the same method as we've just done for the multiplying. We need to find our common factors in the diagonals. So the common factor between 6a and 9x, well, that would be a common factor of 3. So I can divide both of those by 3. So it's 2a and it's 3x. And what is the common factor between 7 and 14? Well, the common factor between 7 and 14 would be 7. So I divide by 7 in both cases. And now all I need to do is multiply across the top, multiply across the bottom. So 2a times 2 is 4a, and 1 times 3x is 3x. So that would be 4a over 3x. So next we have 3x plus 6 over x squared plus 2x divided by 9 over 4x. So we're going to go through the same process again. We're going to copy, change, flip. So we'll start with copying down 3x plus 6 all over x squared plus 2x. We'll change our divide to a multiply, and we'll flip our 9 over 4x to be 4x over 9. And then what should we do? Well, we'll look to factorise, because we need to find some common factors. So if I factorise 3x plus 6, well, that gives me 3 brackets x plus 2. And if I factorise x squared plus 2x, well, that would give me x brackets x plus 2. And I would multiply that by 4x over 9. Now in this case, the first thing we can do is we can say, well, we have a common factor of x plus 2 in the first fraction, so we can cancel that out straight away. But then we want to look at those diagonals to see if there's anything that we can cancel in those cases. Well, on the diagonal I've got 3 and 9. If I wanted to cancel that, well, I would divide both of them by 3. So that would be 1 over times something over 3. And if we look at the x and the 4x, is there a common factor between those? Well, there is a common factor of x, so I can divide through by x. So that would give me 1, and it would give me 4. And so I've got 1 over 1 times 4 over 3. This is all actually exactly the same as, quite simply, 4 over 3. And finally, we have x squared plus 3x plus 2 over 3x plus 12 being divided by 4x plus 4 over x squared, take away 2x, take away 24. And so, what do we want to do? Well, we want to make sure that we factorise, but before that, we want to copy, change, flip. So we want to copy x squared plus 3x plus 2, and we want to copy 3x plus 12, but we want to change it to a multiply, and then we want to flip to make it x squared, take away 2x, take away 24, all over 4x plus 4. So let's get to factorising. So the top one, that's going to be a double bracket because it's in the form of x squared plus bx plus c. I need two numbers that are going to multiply to make positive 2, but add to make positive 3. Well, that's going to be x plus 1 and x plus 2. And all of that's going to be over, well in this case 3x plus 12, that's going to be a common factor of 3, and that's x plus 4. On the right hand side, again the numerator is going to be a double bracket, and I'm looking this time for two numbers which will multiply to make negative 24 but add to make negative 2. Well in this case that's going to be x take away 6, x plus 4, and at the bottom 4 brackets x plus 1. Now again, this is the situation where we now need to start thinking about, can we cancel out? So across the diagonals. So across the diagonal here, x plus 1 with x plus 1 will cancel out. Across the diagonal here, x plus 4 with x plus 4 will cancel out. And so the only thing that we need to do here is we need to do x plus 2 times x take away 6. And that's going to be over 3 times 4, which is 12. And again, that there is a perfectly acceptable answer, but we might just need to expand out the top. So let's call that x squared take away 4x take away 12 all over 12. Okay, and so the last set of examples, these are just the situation where the values within the question have just been made that little bit more complicated by the fact that we have a coefficient of x squared. And so this is just taking it up one stage further, so that we have to recognise, in order to factorise it, that we need to do a little bit more work. So in this case, I've got 6x squared plus 13x plus 6 all over x squared being multiplied by 3x squared plus 2x over 3x squared plus 14x plus 8. And in this situation, this is a multiply, so I don't need to do any copy, change, flip. I just need to leave it exactly as it is. But the first thing I do need to do is to factorise. And so the first thing I want to do is just factorise the expression 6x squared plus 13x plus 6. So 6 times 6 is 36. I need two numbers that are going to multiply to make 36, but are going to add to make 13. So we'd have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Do any of those add to make 13? Well, this pair here works. So let's now rewrite this as 6x squared plus 4x plus 9x plus 6. Well, let's split it and let's factorise the first piece. Well, that's going to be 2x brackets 3x plus 2. And the second piece, well, that's going to be a factor of 3. So plus 3 brackets 3x plus 2. And let's bring them back together. And so this would be 2x plus 3, 3x plus 2. So that is the top of my first fraction factorised. This second fraction has 3x squared plus 14x plus 8. Let's do the same again. We need to do 3 times 8 is 24. And two numbers that are going to multiply to make 24 but add to make 14. Well, that would be 1, 24, 2 and 12, 3 and 8, 4 and 6. Which one adds to make 14? Well, it's this one here, 2 and 12. So we'll rewrite as 3x squared plus 2x plus 12x plus 8. We will split it and we'll factorise. So the common factor there is just the x. So x brackets 3x plus 2. And on this side, the common factor between 12x and 8 is 4. So 4 brackets 3x plus 2. And let's bring them back together. That would give us, in a bracket, x plus 4 brackets 3x plus 2. So now that we've got all of this, we just want to put it back into the terms of the fraction. So we would have 2x plus 3 brackets 3x plus 2, and that is all being divided by x squared, and that is being multiplied by x plus 4 3x plus 2. But at the top, we do just want to factorise the top here as well, just in case. Well, in this case, I can see that there is a common factor of x. So that's going to be x brackets 3x plus 2. So x brackets 3x plus 2. And so, let's have a look. Can we cancel anything out? Well, actually, straight away, this second fraction has 3x plus 2 on the top and bottom, so we can cancel that out straight away. Then we want to look to see if we've got common factors anywhere else. So along the diagonal here, is there a common factor between 2x plus 3, 3x plus 2 and x plus 4? There isn't. We've already actually dealt with one of them. And between x squared and x, is there a common factor? Well, yes, we can cancel out the x, which actually makes the top of this fraction now just 1. And we'll cancel out the x here, which means we don't have the x squared anymore, just the x. And so, in this case, what we end up with is going to be 2x plus 3, 3x plus 2 multiplied by 1. So we still have 2x plus 3, 3x plus 2. And on the bottom, we have x times x plus 4, which we would just write like that. And again, if we wanted to expand that out, we could, but that is a perfectly acceptable answer to this question. And now we have a division question again. We have a coefficient of x squared in two of our expressions, so we're just going to need to deal with those first. So let's just take the first expression here. I need 2 times 6 is 12, so I want a pair of numbers that are going to multiply to make 12 but add to make 8. So I'd have 1 and 12, 2 and 6, 3 and 4. Well, that gives me 2 and 6 as my answers, and so I'm going to have 2x squared plus 2x plus 6x plus 6, and I'll split that, and that would give me 2x as my common factor and x plus 1 in the bracket. And in this case, to make sure that I get x plus 1, well, that would be 6 as my common factor. Bring them back together, 2x plus 6 and x plus 1. In the right hand side of this, we have 3x squared plus 2x take away 8. So I want to do 3 times 8, negative 8 is negative 24. So I need two numbers that are going to multiply to make negative 24, but add to make positive 2. So negative 1, 24, 1 and negative 24, 2, negative 12, negative 2 and positive 12, 3, negative 8, negative 8, negative 3 and 8, 4 and negative 6, negative 4 and positive 6. Which one is the pair that makes positive 2? Well, it was actually the very last one, negative 4 and 6. So that becomes 3x squared, take away 4x, plus 6x, take away 8, and we'll split that in half. What is the common factor between 3x squared and 4x? Well, the common factor is quite simply x, so that's 3x take away 4. I need the same bracket on this side, so 3x take away 4. And so what do I multiply 3x by to make positive 6? That's positive 2, and it works for the other piece. Bring it back together. I get x plus 2 brackets 3x minus 4. And we want to factorise the top and bottom of each of these expressions. There's a lot of work going into this question. So we've just said that the first fraction was 2x plus 6 x plus 1. And the bottom of that fraction, well, if I wanted two numbers which were going to multiply to make 4 and add to make 4, well, that would have to be x plus 2, x plus 2. And then on the other side, we've just worked out that the bottom should be x plus 2, 3x minus 4. But all I want to do is I want to just do my copy, change, flip at this moment. So I'm going to copy, I'm going to change to a multiply, and I'm going to flip. So this is now going to be at the top. So x plus 2 brackets 3x minus 4. And the bottom of my fraction, well, in this case, I need two numbers that are going to multiply to make negative 3, but add to make positive 2. Well, that's going to be x plus 1, x take away 3. And then we now need to just look at our diagonals and see if we can cancel out any common factors. So a common factor here is x plus 1, so we can cancel those. Common factor here, well, we have an x plus 2 in both. And so all we need to do now is multiply. So if we multiply across the top, what we get is 2x plus 6 and 3x take away 4 all over x plus 2, x take away 3. And we now have the final answer to our question. And we end with our exam question, and this one came from the Edexcel mock papers, and it was on higher paper 1. And the reason I wanted to show you this question is just to see the way that these questions are sometimes asked. So it says, show that 1 over 2x squared plus x take away 15 divided by 1 over 3x squared plus 9x simplifies to ax over bx plus c, where a, b and c are integers. Now this whole section here doesn't actually mean anything unless you want to check your answer at the very end, because all it's saying is find 1 over 2x squared plus x over, take away 15 divided by 1 over 3x squared plus 9x, and it's just saying that at the end you'll end up with something x at the top and you'll end up with something x plus c, something at the bottom, and all of those values will be whole numbers. And so all you need to do is just check whether that is the case. So, what is our rule for dividing with fractions? Well, the first thing is that we do copy, change, flip. And so we do 1 over 2x squared plus x, take away 15. We change to a multiply, and we flip 3x squared plus 9x all over 1. And what we can do straight away here is, just thinking about our rule for multiplying, we cancel out common factors. Well, straight away I can write that as a single fraction, because I've got 1 at the top and I've got 1 on the bottom of the two fractions. So I've actually got 3x squared plus 9x all over 2x squared plus x take away 15. Now if I want to simplify that, which it says simplifies to, well, I'm going to have to actually do some factorising of each section. So I'm going to begin with the bottom, just because I know that's going to be the slightly more complicated bit. And so I'm going to do 2 times negative 15 is negative 30. And I want a pair of numbers which will multiply to make negative 30, but add to make positive 1. Now, in this case, we could have 1 and 30, 2 and 15, 3 and 10, lots of others, but in this case, I know it's going to be 5 and 6 in some way, because I know that the difference between them must be 1. And if it's going to make a positive 1, the 6 must be positive and the 5 must be negative. And so the bottom of my fraction here is going to be 2x squared take away 5x plus 6x take away 15. We'll split that in half. What is the common factor between 2x squared and negative 5x? Well, the common factor is x, so it's x brackets 2x take away 5, and in this case it will also be 2x take away 5. And so what do I multiply 2x by to make plus 6x? Well, that is plus 3. Bring them back together. I get x plus 3, brackets 2x, take away 5. And that is going to be the bottom of my fraction. So that's x plus 3, 2x, take away 5. The top of my fraction was currently 3x squared plus 9x. Let's factorise that as well. What are the common factors? Well, there is a common factor of 3, but there's also a common factor of x. And so that's going to be 3x times x plus 3. And finally, are we able to cancel out any common factors? Well, we have x plus 3 and we have x plus 3. And so this fraction simplifies to 3x over 2x take away 5. Now, does that meet the criteria of what they told us? They said it was going to be ax over bx plus c. Ax over bx plus c. Now, something that a lot of people will look at here is they'll say, well, yes, I've got something x at the top, I've got something x at the bottom, but then it's got negative 5, whereas this says plus. That does not matter. Plus c just means it could be plus a negative number, which it is in this case, and so that is exactly right. It is 3x over 2x take away 5.